This lesson is about the hyperbola for FET. Now, a hyperbola can be given by x multiplied by y x multiplied by y is equal to a constant. Therefore, we can say x is equal to k over y. In the same way, y can be equal to a constant over x. Let's say k is equal to 8. Therefore, this will be if k is equal to 8. Therefore, we have 8 over y. And here you have 8 over x. That being the case, this says it implies that y will never be equal to 0 because 8 divided by 0 is not allowed in mathematics. In the same way here, similarly here, x cannot equal to 0. Now, this constitutes the asymptote. The asymptote, the x and the y asymptotes. X and the y asymptotes. It's supposed to be x and the y asymptote. What does this mean? It shows that if you have a Cartesian plane in this format, the graph will be this one here. Your graph will be of this shape here. Because the constant is positive, it will be in the first quadrant and the third quadrant. Because k is positive, your constant is positive 8 there. The graph, the curve will be on the first and the first quadrant here, the second quadrant here, the third quadrant there, and this will be the fourth quadrant. That's what you have. If k is negative, your graph will be here. This is for y is equal to negative 8 over x. If your constant is negative, the graph goes to the second and the fourth quadrant. Take note. Now, let's see what is going to happen. If you come up with a function of this form, sorry, excuse me, we have y is equal to 8 x minus 1. Now, for this fraction to make sense. For this fraction to make sense, x minus 1 cannot equal to 0 or must not equal to 0. And that's only possible if your x is equal to a 1. If x equal to a 1, it will be 1 minus 1, and that will be a 0. And then this is not allowed. This denominator will be 0 if, excuse me, x is equal to 1. We don't want that the denominators will be 0 because division by 0 is not allowed in mathematics. Therefore, we will say x is equal to 1 is an equation for the x asymptote. Now let's see what's going to happen when we draw a graph of that nature. You will have, if you have a Cartesian plane, now we agree that your x can never be equal to a 1. So that will be 1. So here, this will form the x asymptote. Therefore, your function will be that when x is a 1, the graph will go to infinity, runs away from that. And then this one, when it is 1, it runs away from it. That's what we have. Now, you can see that y asymptotes remains 0, meaning if you move here, you have 3, 2, 1. When it goes to 0, the graph runs away. At 2, you can touch the graph somewhere there. At 3, you can touch it somewhere there. At 1, you can touch it somewhere there. At the half, somewhere there. But when it's near 0 here, it goes to infinity. It runs away. It's an asymptote. So you realize that this figure here has shifted our previous function, this one here, 1 unit to the right. This function here in black has shifted 1 unit to the right because there's 1 unit there on this side, moved that way. So it has moved 1 unit to the right. So this number here is responsible for the shifting of the function to a left or right. If we had f of x is equal to 8 into x plus 2, we will expect that to move the graph here to the left by 2 units. Why? Because x plus 2 is equal to 0 if and only if x is equal to -2. So -2 becomes the asymptote, your x asymptote. Now let's go further with this function here, saying f of x, which is y, of course, is equal to 8 into x minus 1 plus a 2 here. Now, on the previous graph, we realized that this graph is passing the y-axis there. And then we need to know at which point does the graph pass the y-axis. Now let's go to the current function. The current function is f of x. Open now. The current function is f of x is equal to 8 x minus 1, a set plus a 2 here. Now this is have taken this form. F of x is equal to a x minus p plus q, where 2 is your q. And then let's see what happens. Now, if we take a simple parabola, this can be sketched quickly that if I have f of x is equal to x squared plus 1, let's say plus a 2 there, it's going to be 1, 2, the graph shifted 2 units up. It was here, it means it intercepted the y-axis at 0. Now it's intercepting the y-axis at 2 because of that 2 there. This is playing the same role as that 2 here. If you remember, in the previous lesson, we had f of x is equal to a x squared plus a q as an equation for a parabola. Now, equation for hyperbola is that now this determines the x-intercept, and then this determines the y-intercept. This determines the y-intercept, and this will determine the x-intercept. Basically, no, not the y-intercept here, not the x and the y-intercept, I'm sorry, but this determines the asymptote, the x and the y asymptote. So here you can say the y asymptote is 2. If the question says, give the equation of the y asymptote, you say y is equal to 2. That's an equation. And an equation for the x asymptote will be x is equal to 1. These are the equations for the x and the y asymptote. Now let's have a look at the shape that this function will take. Now, we say we agreed here that y, there is a line that is going to pass here at x is equal to 1. That's our asymptote. And then there's a line here at y is equal to 2. Equation of the y asymptote that goes down here. It will go there. Now, the function will take this form here, running away from 2, running away from x is equal to 1. That's your equation. That's your function. That's the function. Then this one will come and pass the y-axis, come past the x-axis, go down there. Now, our challenge is to find the point where the graph passes through the x and y intercept. Now we use what you know, that for the x-intercept, you let y equal to 0, and for the y-intercept, you let x equal to 0. So for the y-intercept, not the y-asymptote, the y-asymptote is given as 2, the x-intercept, we let, for the y-intercept, let x equals to 0, we let x equal to 0, you let x equal to 0. And then if you let x equal to 0, we have y is equal to 8, 0 minus 1 plus a 2. That will be 8 over negative 1 plus a 2. That will give you negative 8 plus a 2, and that will be negative 6. So we said x is 0, y will be minus 6. That's what you have. So it must pass the y-axis at minus 6. Let's look at for the x-intercept. We put y equal to 0, we have 0 is equal to 8 into x minus 1 plus 2. We are going to transpose the 2, going to be negative 2 is equal to 8 into x minus 1. If we invert or we cross multiply, we'll have negative 2 into x minus 1 is equal to 1 times 8. We have negative 2 into x minus 1 is equal to 1 times 8. We have cross multiplied. That's negative 2x plus 2 is equal to 8. Negative 2x is equal to 8 minus 2. That's 6. That's your negative 2 there. We divide by negative 2 there. Divide by negative 2 there. That gives us negative 3. Therefore, your x will be at negative 3. There's a negative 3 there. Means your graph will come this way, past negative 3. Negative 6 will be somewhere down there. And it's going to pass negative 6, going that way, running away from x equal to 1, because your x here is equal to a 1. So it can come this way, and join that. That's what we have. It must be a smooth curve coming that way. It must be a smooth curve coming this way. Not this monster that I've written. It should be a smooth curve coming this way. Now that's what you have. Now, there are a number of things that we can get from this function here. One, if you look at that function, you will appreciate that this is the point of intersection of the asymptotes. X here is 1. The coordinates here, y will be 2. The coordinates for this point here will be 1 and 2. Now, if you draw a line this way, passing here, the two graphs should be symmetrical, which means the graphs are supposed to have been somewhere there. So that this distance from here to there must be same distance from here to there. Okay, so we can improve this function here by saying this function from the drawing, it should have been far from where it is now. Should have been far from where it is now. The graph should have been something far like that, but running away from x equal to 1, running away from y equal to 2. Therefore, right, with that kind of a graph, this is just a rough sketch. It's not drawn to correct measurement here, scale, but The mathematics is that this line here is a line of symmetry. It casts that half to this half here of the function equally well. Now, let's have a look at if somebody gives you a rectangle. Somebody gives you a rectangle. This rectangle here is symmetrical halfway there. It's also symmetrical halfway there. You can also draw another line of symmetry here. If you move from here to there, this top part is the same as that top part. They're symmetrical. If you cut it horizontally, vertically, this part on the right is the same as on the left. If you cut it horizontally, that way, we expect this part here to be the same as the bottom part there. So that's a line of symmetry. So when you talk about the axis of symmetry, we mean that if you cut the function here, this part will be the same as the mirror image of this one. Now let's look at another one. If you move from here, if you move from this point here, and you go up and you come down, that is also the axis of symmetry. Down below this orange line, you have this function going there, the function going there. Above that orange line, you have this is a mirror image. If you put a mirror here along this line here, what you see here will be what you see up there on the mirror. If you put a mirror, if you face the mirror this way, you'll see on the mirror the curve going down this way. But one thing, if you have a linear function, if you have y is equal to mx plus c, and if you say your slope is positive, the graph is increasing. If you move from your left hand to your right hand, you must go up. It's increasing function. But if m is negative or less than 0, like y is negative 2x plus 4, the slope of this function from my left hand to my right hand, I must go down. I must go down. This is decreasing function. Now let's go back to our work. Here, you have the equation of this line here, which can be written as y is equal to mx plus c. M is positive, but this one here can be written as y is equal to negative. Because from my left hand to my right hand, I go down, it's decreasing. Here, from my left to my right hand, I go up, it's increasing. Now, examiner will ask you to give the equation of the axis of symmetry with a negative slope, or he can say give the equations. What's the both equations, positive and negative? Now, let's look at both equations. Let's look at both equations. Let's look at both equations and see what's going to happen on that function there. We are looking for the equations of the axis of symmetry on a hyperbolic function. Now that's where we start. We have y, because those are straight lines, they must be given by that form. That's what we have. And the other one is y, negative slope plus c. Now, let's go back to the function itself. At this point here, you see the two functions or the two symmetries are passing there, then the lines of symmetry are passing at this point here. And we agree that x is 1 and the y is a 2 as a coordinate there of the intersection of the asymptotes. So we are going to substitute that. We have x and y in that form. That's a coordinate. That is a coordinate, x and y. That's a coordinate. Now that's what we have. Y will be 2. Y will be 2 m, and the x is a 1 plus a c. But for the equations of, we write y is positive x plus c and y is negative x plus c. These are the equations of the asymptotes, here with a negative slope, here with a positive slope. So it's presumed that m is 1 on this equation here. So let's take the first equation here. Y is a 2, x is a 1, or x is a 1 there, plus a c. Therefore, c will equal to transposing the 1 here. So the c will be a 1. And that equation can be given as x plus a 1. Let's look at this equation of the axis of symmetry, where the slope is negative. We have y. We said our y is a 2. So we have 2, which is equal to negative x plus a 1. No, it's supposed to be a c. And then our x there is, of course, a 1. Our x is a 1. So c will equal to 2 minus a 1. So c will equal to a 1. So the equation here is going to be y negative x plus a 1. That's what you have. So these are the equation of the axis of symmetry of the two of the function there. Now, what it means is that What it actually means is that the other one is passing the y-axis at -1. But I see one there and one there. Okay, so this equation is negative. It's a negative slope. This equation here is for a negative slope, and that equation there is for positive slope. This is negative slope, and then that one is positive slope. So please don't forget that when you want to get the equation for the axis of symmetry of hyperbola with a negative slope, we use this one, and with a positive slope, we use that one. Thus far, how you draw the graph of the hyperbola. Hope you understood that, and you can leave your comments on your comment section.